Good evening, all of you. So, I will introduce myself at the end so that the people who are joining a little late also will be able to hear that. So, I'll be introducing myself at the end of the session. So, what do we do now is we are going to straight away start with the technical topic that we are supposed to start here today related to the telecom fundamentals. Um, So before going into this technical topic directly, I would like to give a overview on what is this is all about. For the first few classes, especially the first 5 or 6 classes, we'll actually be introducing all the basics on telecommunications, 2G, 3G, 3.5G, etc. And then we slowly enter into 4G. You may be asking a question that I have already been working on telecom domain for a long time, and I already knew 3G, 2G networks, and I don't want to learn it again. We are not going to teach 2G, 3G from, is not like we are teaching it again. We are going to teach all the basics of it, which are required technically to be able to understand the handovers from 4G network to 3G or 4G network to 2G network, to be able to understand that. And moreover, the people who are joining into these sessions are going to come from different backgrounds. None of you coming from the same background, and I cannot expect a common kind of a knowledge from every person. So that is why what do we do at T Cloud is we start teaching everything from the scratch, from the basics, the fundamental concepts, and then we go further on to the subject, and we will be we'll be teaching you the deeper topics. So even though the subject may be repetitive for you at the starting, you may be like you may already know 80 to 90% of the subject in the first 1 or 2 sessions, but you still will able to learn the remaining 10 to 20% of the subject. In the later sessions, when the sessions keep going by day by day, your learning percentage will keep getting increased. So after 1 week, whatever the subject that we'll start introducing will, all the subject will be unknown subject for you. But while your first few classes, like some subject you will be knowing about it already, and some subject you will be learning for the first time. So it is very much required for bringing everybody to the same level before we start teaching the deeper concepts. That is why we start introducing telecom fundamentals with this particular part, Pstn and Plmn introduction. So we see what is it and how these are going to be introduced. So telecom fun or telecom fundamentals. Uh, we all know that our telecommunication world started with this, where Graham Bell invented a landline phone, which is basically having a mouthpiece and a earpiece. Earpiece will go on to your ear, and on mouthpiece you will be speaking. This is the technical representation of the real-time device. This right-hand side part is the real-time device that put it in the art form, in the form of a picture. So we are going to start everything from what happened, how the technology is evolved from the days when Mr. Bell invented this device to the day we are in today. So we are going to see all the major technology breakthroughs in the middle, so that we'll have complete idea on how the technology got come to the today's stage. We will have a complete and clean idea on that. So the first network that we are introducing in telecommunications is PSTN, Public Switch Telephone Network. That's the name, shortcut name is PSTN, by taking the first letter of all these words. What does this public switch telephone network represent? How it was evolved over the time? First, we start with that. So when Mr. Bell or Graham Bell invented this telephone. So the invention was simple like this. There were two devices, and one device is, Mr. Bell was talking, and the other device, his secretary was there, and both of them are actually communicating with each other, you know, um, when they are apart like 100 meters or 150 meters of distance. So they have communicated with one another. Uh, so the device as an experiment is working, but they wanted to implement it in the network, in the real world. So when any kind of a solution that is developed by any scientist, when it has to go into the real world, you have to start thinking about what are the different ways that we can implement and in the real world. So you have to start thinking about it. Obviously, everybody loved this idea of these devices which can communicate with each other from a distance. Obviously, everybody loved it. But the problem is, how do we implement it in the real world? What are the different ways that we can do it? Now, one of the way they thought is, um, you know, make a connection from every device to every other device. This was one of the possible solutions, typically end user switching. So, if you take the first device, there are going to be three wires coming out of this first device leading to each of the other devices. The three wires are leading to. Same situation with other devices also. From every device, three wires are going out and reaching to the other three devices. Now, what is the meaning of end user switching? Even though there are three wires in your house, the user who wanted to make a call, for example, if a human being is here, if he wanted to make a call, out of the three wires, it will be selecting which wire, you know, he wants to connect to this device. He will select it. So basically, the end user will decide what wire should be connected. Based on which wire is connected, now based on that, you will know like he is willing to communicate with which other human being who is part of who is present with the other devices. For example, if you connect this wire, so the communication will happen between this device to this device. If you connect this wire, you go here. If you connect this wire and you go here. So it's that way. So what is the meaning of switching? Switching is like if you generally use this word switching, which represents like changing. For example, if you take these three wires, you can keep on changing them from one wire to the other wire, basically, like depending on to which device you would like to communicate with. So who is switching it? Who is changing these wires and who is making the communication happen? The end user himself is doing it. The end user who is associated with the device is doing this job. But the biggest problem is when the devices kept on increasing, the number of wires will keep on increasing. And at one point, if there are 1,000 devices in the world, then from every device, you need to lead 999 wires out. And 999 wires will be leading to the remaining 999 devices. And the job for the public, the job for the user becomes much more complex. Why? Because there are 999 wires in your house. You need to pick up one of the wire from those 999 wires to be able to make a call, to be able to be speak to one particular person. You have to pick up the corresponding wire and connect that wire to your device so that you can actually make a communication with one particular device out of the 999 devices out there. That is not a great solution because your house will look messy with these many number of wires. End users won't like it, and end users don't want to do that much amount of hard work of picking a wire from thousands of wires that have led into their home. So even though this technically the solution is possible, it is not an implementable solution. Humans won't like it. So that means, what is the first thing that we are learning here is very important. When The technical solutions are built by different organizations or scientists. There could be a lot of technical solutions possible, but when we wanted to implement the solution in the real world, we will always be choosing the best implementable solution. Now, what that tells us is, even though a particular solution is implemented in the real world, that doesn't mean that that is the only solution possible technically. It is not the case. So there could be n number of solutions possible. For example, is the solution technically possible? Connecting all the devices with each device with a wire to other device. Technically speaking, it is possible, but in the real world, it is not feasible. So there are possible solutions and feasible solutions always. So this is a possible solution, end user switching, where end users can pick up the wire um, based on the device they would like to communicate with. They can pick up that wire. Is it possible? Yes, it is possible. Can you lay down that wires? Yes, we can lay down that cables. Not a problem. Of course, you need to invest a lot of money, but if you put that money part aside, you can still invest it and you can still implement this solution in the real world. It is possible, but it is not feasible because users are not liking it. There are a lot of disadvantages with this. Too much money for the implementation, as you are leading down a lot of cables. For example, if a new device comes up in Australia, you need to lay down a cable to that Australian location immediately because you want to communicate with that device also. So that Australian device which has come up just now have to make cables to every other device in the world, okay, to have the communication going on. So that looks really, really bad for implementation point of view. So they thought that, hey, we should go for a different kind of a implementation, even though the previous one is possible. So what did they propose in this implementation? Said, hey, we take one some kind of a exchange in the middle, and all the devices would get connected to this exchange. Instead of directly connecting all the devices to all the other devices, we are connecting all the devices to the central exchange to one port. And what do they do after that? After that, they, depending on which users they wanted to communicate, they are going to employ one kind of a human in the middle, who is, we call them as simply operator. So operator is employed on the switch. So the duty of the operator who is employed in the middle is make a connection between the devices that want to communicate with each other. So the operator is making that loop or making that link, or we call it as a circuit. Okay, so is actually completing the circuit. So when the human who is sitting at this device wanted to make a call to the human who is at this device, so this guy does something with his electronic device. Maybe there will be LED light here or whichever it blinks. So a wire will be connected to the headphone of this operator, so that whatever this guy speaks, this operator will be able to listen. So this guy tells him that, hey man, I want to talk to so and so person. So immediately he'll take out his headphone wire from this port, and he'll be connecting this port and to the other port that is leading to this particular device. This is what we call as manual exchange switching. As part of it, now the switching operation happened. We have switched from one port to the other port. We have linked. We have formed a circuit. Now, it is almost equivalent to having a direct wire. If you actually observe this picture carefully, it is all it there is no difference between having a direct wire between one device to the other device. Both these options are same, but instead of having one wire, here we are having basically three pieces of three wires here, three pieces combined with a joints in the middle. That's all. One wire is from the device to the exchange. The other wire is from this port to this port, and the third wire is from this port to the other end device. So ultimately you have made the circuit, you have made the loop, you will be able to communicate with the other device. But how long this circuit would be there is only for the for the duration when these two users are communicating with one another. After the communication is finished, so the circuit will be removed by the operator in the middle after the communication is completed. So the operator's duty is to keep making these connections somehow between all the among all the devices whoever want to communicate, and keep removing those connections and keep all the ports free at all the times, at least the ports that are not communicating right now. So you have to keep them free. So that's the duty of the middle operator guy. So this is a better solution than the previous one. Instead of end user switching, you don't need to maintain thousands of wires. Even though there are thousands of devices, thousand devices are there, all the thousand devices would get connected to the exchange ports. And there is an operator operating 24 by 7 and making connection between one port to the other port. Implementing this is not a big deal, because even if a new device is coming up, you need to only connect that new device to the exchange. You don't need to connect that device to every other device. Not required. You need to connect the device only to the exchange, to one of the port in the exchange or one of the empty port in the exchange. So when you compare the previous solution and this solution is much, much better for implementing in the real world. So obviously this is what they have implemented. So if you see a real world situation from the old days, nowadays we don't do it, but in the old days they used to do this. So these are the humans who are actually connecting the ports that are leading to different devices. They are taking one port and joining or connecting it to the other ports that are leading. So now you can just imagine each hole that you see over there is actually a port leading to one device. Now you can just imagine like thousands of users. Because there are thousands of holes you can see, and thousands of devices connected to thousands and thousands of customers, and these people who are operators, they are actually like making those links and establishing the end-to-end connection or end-to-end switching. Now, uh, now the next thing that we will be thinking there is very simple. Can we implement this solution that we have, that one solution we have with one switch in the middle? Can we implement it as a worldwide solution? Now that is a problem when we want to implement it as a worldwide solution with a single switch in the middle, or with a single exchange in the middle. The reason is, for example, let us take that if that switch is kept in India. Now, if any device comes up anywhere in the world, from that device you need to have a cable laid down to this particular exchange that is present in India, because exchange is only present in India. Now that's not practically, you know, it is not practically implementable. For example, just imagine the effort of laying a cable from US to India, a single cable connecting you to all the way to the exchange. That's really an big task when the number of users are present in different countries and different places. So obviously they started thinking, hey, we should solve this somehow, and they started thinking about this manual exchange switching, having multiple exchanges. As you can see over here, we have multiple exchanges here. So they started dividing the exchanges. They started spreading different exchanges in different locations. So some users will get connected to first exchange, some users would get connected to the second exchange, and of course we connect these exchanges as well with the ports. So there would be two operators instead of one, and the devices are definitely connected to both the exchanges. So we have some human beings on one exchange, some human beings on another exchange. Now, if you wanted to make a session, or if you wanted to make a call from one device to the other device, now two operators will have to play the crucial role. The first operator who is in the first exchange is going to make a connection between this port to the port that is leading to the other exchange. So it will be joining these two ports. Now, once the situation is known to the second operator will be able to make a connection between this port to this port, leading the communication to the other end device. Ultimately, it doesn't matter like how many exchanges we are going to have, how many joints that we are going to link up to create one circuit or to create one loop between two end devices. Doesn't matter. But ultimately, you must be having a circuit, whether that is having three joints or five joints, it doesn't matter. Here, if you take this case, we are having five joints here totally. So this is one piece of wire, this is another piece of wire, then this is the third piece, fourth piece, and the fifth piece. In earlier case, we have joined only three pieces together and made a circuit. Now we have joined five pieces because both these users belongs to two different exchanges. Okay. So still we are having a single wire solution only from each and every device. That single wire will lead to an exchange. You can connect the exchanges together to have the communication between any two devices that you wish. Fine. Now, but the problem happens with humans increasing is the number of exchanges started increasing, because there will be thousands and thousands of users in each and every geographical location. Everybody wanted to have a communicating device like a telephone. They wanted to be connected. So obviously you need to maintain a local exchange. So the number of exchanges starts increasing. You cannot have only two exchanges in the world, like one in US and one in India, or maybe one in UK. You cannot have like that. So there will be hundreds and hundreds of exchanges coming up. Now the biggest problem when we have these many exchanges is you need to have a communication between each exchange to each other exchange, because the humans who are present under one exchange, they don't want it to be restricted. They don't want to be only connected to users under only some few exchanges. No, they want that, hey, I must be able to talk to anybody in the world, anybody who is present on any exchange. I don't want any kind of restrictions at all. So to achieve that, you need to connect every this exchange to all the other exchanges. So if you do that, after doing it, you can make a connection. You see, you can make a connection from this device to this device by using this linking. But the users who are under this exchange, because this exchange is connected to all other exchanges, users under this exchange can communicate with the users under any other exchange possible. But when there is one user over here in this exchange, there is another user over this exchange. If these two guys wanted to communicate with one another, right now there is no solution. Actually speaking, there is a technical solution, but there is no direct solution between these two exchanges. Reason is these two exchanges are not having any connectivity with each other directly. So the users under these two exchanges are secluded. They can't communicate with each other as there is no communication link between these two exchanges. So obviously, what will happen eventually is when the user started demanding that we must have communication with every other user in the world, then you need to have connections among all the exchanges. So every exchange must be connected to every other exchange. Okay, this is still a problem. This is a bloody bad thing. We don't like it because if there is a new exchange coming up in a country like Cambodia, now that exchange must be connected with every other exchange in the world. So there should be wires drawn out from Cambodia exchange to every other exchange in the world, to a exchange in Hyderabad, to a exchange in Bangalore, to an exchange in Mumbai, Bombay, etc., etc. So you have to connect to every exchange in the world. No, not good idea. So even at the exchange level, we cannot connect every exchange to every other exchange because there will be lakhs of exchanges in the world. So what do we have to do? How do we solve it? So they started thinking that we need to create some kind of a hierarchy. So they have started creating central exchanges, and all the other exchanges would get connected to this central exchange in the middle. So basically, these central exchanges won't contain any end user devices by themselves, but their only duty is to have interlinking between the exchanges. Their only purpose of existence is to interconnect the exchanges. They won't be connected to any other individual users, individual devices. Now, when you have that central exchange, you can make a call between, you know, any devices to any devices. For example, we can make a communication from this device to this device by connecting this port to this port. We'll be able to make a connection from here to here. Then this is already connected to the main exchange. From this port, we can lead to this port because it is leading to this exchange. From this port, we lead to this exchange. Finally, from this port to the end device. Similarly, now from this end use device to this end device also you can make a connection here. This is already connected here. When you link this up, this goes here. From here you link it up to this place and you will you are already connected to the end device there. So when you have an centralized exchange in the middle, you can actually start making the loops between any end device to any other end device with the help of these centralized exchanges. So what kind of architecture they have created is, instead of um, connecting every exchange to every other exchange in the world, so they have connected some n number of exchanges to a central exchange. Now, even they don't connect every central exchange to every other central exchange directly. Instead of it, they will even create another level of centralized exchange in the middle, and they will actually interconnect those exchanges to that centralized exchange in the middle. So, if you take it in a generalized architecture, which you can understand at human level, village level exchanges would get connected to a mandal level exchange. So all the village exchanges would be integrated at mandal level. So all the mandal level exchanges would be integrated at a state level exchange. So all the state level exchanges will be, or maybe mandal is into district, district to state. All the state level exchanges would be integrated at country level. Your country level exchanges would get integrated at an international level exchange. So some kind of an hierarchy got created in your Pstn, public switched telephone network. So they have created a hierarchy. So if you want to make a call from any device to any device, it is absolutely possible. There is no problem at all. For example, a device which is present in this village and another device present in the same village, if two devices are present here in the same village, you can actually make a connection. You can actually make communication between those two devices without even going to any other higher level exchanges. It is not required because both the devices are connected to the same village level exchange. You can directly join those ports together to make the communication possible. But if one device from here, if you would like to make a connection to the other device that is present somewhere else, for example, if you want to make a call to the device which is connected to this village guy, now the communication is going to be a different strategy. Now we have to reach through a different path. First, we need to go to village level. From there, we reach mandal level, then we come back to this village level, then we have the connection to the end device. So depending on between to which devices you are making the communication, your path is going to be different. For example, there could be a device here which would like to make a call to a device here. So obviously what happens is it goes to mandal level, district level, it end up at state level, country level, finally it has to go to international level, because both these exchanges belongs to two different countries, and they will come over here, and then the state 2, and then district 1, mandal 1, and then we'll reach the village 1 to that particular end device. So, without having a direct connectivity between any two end devices, by maintaining this kind of a hierarchy, they have created an architecture where you could make a call from any device to any device in the world by using this hierarchy. That is what you typically do in the landline phones. If you make a call to a local number, landline number, you can dial directly the number itself. But if you are making a call to some other number which is present in a different location, you will use a STD code. But if you want to make a call to a landline which is present in a different country, you have to use a ISD code, international code, so that the call details will go to international exchange, and that guy will decide to forward it to the corresponding place depending on the need. So the PSTN is basically a hierarchical architecture with all the landline phones connected with each other um, in a hierarchical structure, with exchanges connected in hierarchical structure. Even if a new exchange comes up tomorrow, the worldwide architecture won't change. For example, if a new exchange is coming up tomorrow somewhere here, maybe a village 3 is coming up here somewhere, that's all. That village 3 will be get connected to this mandal 2 exchange. That's it. You don't need to lay down thousands of cables and lakhs of cables to be able to connect those devices to all the other devices in the world. Not required, because the mandal is already connected to district 2, district 2 is already connected to state 2, state 2 is already connected to country 2 exchange, country 2 exchange is already connected to international exchange. So all the village, these village users, the village 3 users who are coming up right now, they can make a call to anybody in the world, because you just need this connection, that's all, to the mandal level. Nothing else is needed. So that is the advantage of creating the hierarchical architecture for the telephone environment. I hope you're getting the point there. Okay. So the final solution that is implemented into PSTN, uh, at first it was a manual switching, and after that it was, you know, a switching in the middle, something called as, we have called it as an exchange in the middle. Operator is doing the switching, switching the one port to another port, linking one port to other port. The technical word that we use always is switching. Switching is basically making that loop or making that link, connect different units. The final solution is electronic exchange switching. So what is this electronic exchange switching? So what was the human being doing in the middle by playing a operator role? What the middle human being is doing? So they wanted to replace this human being with a electronic device which automatically does the task instead of human being doing it manually. If you don't do this electronic mechanism, maybe like you know, a lot of human beings would be working in the telephone exchanges itself, connecting the ports and working on the, making the circuits. Yeah, almost maybe like you can say 1/10 of the human beings would be working in telephone devices only, on telephone exchanges itself, if we do not introduce the electronic switching. So they wanted to replace the human being with automatic devices. So they started thinking, hey, if you want to replace a human being, what exactly should be present in this electronic device? What should be the capabilities of the electronic device? They started thinking about it. And the solution they have got to is this. Okay, so the first thing that they need is this electronic device will be able to make a circuit linking between the two ports automatically by using a electronic mechanism, by using electrical circuits or electronic circuits, it must be able to make link between one port to the other port automatically by looking into some numbering scheme, by looking into some numbers. The switch itself will recognize that. So instead of you calling the operator and telling to which number you want to connect, what do you do is on your device, you will feed in some number. That number information electronically will be transferred to the electronic device in the middle. The electronic device in the middle will read that numbers, and automatically that electronic device will create a electronic circuit with the other port without human being present there and physically connecting the male ports to the female ports. You don't need to do that. You by normally operator, what does you do? It'll take a female, two male ports and connect to the two female ports on two ends of the devices. But you don't require that on an electronic device, because electronic device is capable of automatically creating a circuit between one port to other port without the human beings intervention. So by using some electronic numbering, instead of human beings uttering the number with their mouth, we are just dialing the number. We are sending the number to the electronic device in the middle in the form of an digital number. So by reading that input, the device will automatically connect to the corresponding port electronically. But is that it? That is the only logic that the electronic device should contain, or the electronic device must contain anything else? That electronic device may be equipped with a software and a database as well. Maybe. For what reason? Why do we require a database, and why do we require a software? Like, what is the need for that? Let us think about it. uh, in the old days when the operators were there, when this particular user is making a call, he will actually call the operator and tell that, hey, I want to talk to so and so person. Then typically, let us think about what the operator does. First, he will open a book where all the people's account related details are being maintained in the book. Now, the operator will open the book and read it and understand that a so and so customer who is initiating this call did not pay his bill on his due date. His due date expired 3 days back, but he did not pay the bill. You found out from the book. Immediately, what decision human brain will take, or the operator's brain will take, is this call should not be, completed. I should not do this call because this bugger did not pay the money. So why we should make the call for him? So I should tell him the same thing and cut down this thing. So there is a decision being made by using the information that is present in a book, because operator may not be able to remember the information about maybe thousands of users. He may not be able to remember that many users information, like who paid, who did not pay. So the information typically would be maintained in a book. So by referring to the book details, the operator is making the decision. But now, because we are replacing this operator, a human being's brain, we are replacing it with a electronic device. We must have an the equivalent mechanism on the electronic device. So instead of storing the information on a book, we must store the information on a database. So the database, which is an electronic storage device, will contain the information about the different customers, what kind of services they are having, who paid, who did not pay, whether they have only subscribed for local calls or they subscribed for STD calls or ISD calls. That kind of information would get stored into this electronic database instead of storing it on a book. Now, when a number arrival to the exchange, the electronic switch, before it does the actual switching, with the help of the software, this it will access this database with the help of a software. So the software in the electronic switch will go and access the information present in the database and find out whether this user is really subscribed for this particular service or not. If he is subscribed, first of all, did he pay the bill the last month? If he paid, everything is good. Then the software will give a go ahead to the exchange part, tell the exchange part that hey, everything is good. Now you can actually, make uh, uh, a circuit with the end port. You can do that. I'm giving you the permission for that. So software, with the help of the information present in the database, is making a decision and is actually giving the positive nod or a negative nod to this exchanging component to make a decision, or to make this call or to terminate this call. So what we are understanding here, if you wanted to replace these operators in the exchange in the middle, who are actually connecting the end devices, what do we actually need? We need a automatic electronic device which can make electronic switching from one port to other port, electronic connection from one port to other port. After the software made a decision by looking into the database to provide that service or not on the basis of the subscription details of that user. So these three things that we require in the exchange in the middle. So if we can have all these three things in the middle, we can replace the human beings with this electronic switch, and we can say bye bye to the human in the middle, and automatically the switch will be doing the job 24/7 without any humans. Ultimately, this was achieved or not? Yes. If you didn't make the payment, obviously even if your landline it won't work. Once your payment due is finished, somebody will actually go and update the database and saying so that this guy did not pay the money. So when you try to make a call, it says that please make your payment, then only you can make this call, otherwise you cannot. That means whether the exchange getting your number that you are dialing or not, it is getting it, but it is taking the help of the software and making a decision that you are not allowed to use that service. The details are available in the database, so somebody is updating this database. So now we have to employ some people to update this database, obviously. So somewhere humans must be there, so humans might be there updating the database and telling which user is subscribing for what services, and which users paid the money, which users did not pay the money. But to do the switching, we don't need a human being. To update the database, we might require a human being. This is one change that happened. On top of it, those other change obviously is, instead of you telling anybody or you telling your operator to which number you want to make a call, you simply dial the number. That number also will be sent electronically, digitally. That number information will be forwarded to your exchange in the middle automatically. So the dialers have got changed, timely from one generation to other generation. Finally, we got to that the last device on the right hand side. We led to that device where you dial the number and the number goes out to the exchange. So the final architecture of PSTN is this: the PSTN service architecture. Why are we calling it as a service architecture? What is the meaning of service? This PSTN, the packet switch telephony network, is a telephone network basically providing some services to the end user. What kind of services? Call services. What services it is providing? It is making connections or calls to the other devices. It is it is providing us some services. Okay, great. Now, what is that exchange in the middle containing? It is containing an automatic electronic switching mechanism which can switch from one port to other port by reading the digital information or a number, the phone number, after your software made corresponding decision by looking into the database. So that is the part your exchange is containing. But obviously there is no need that this end user may wanted to make the call to the user who is present in the same exchange. Maybe may not be. Uh, Maybe this guy is making a call to some other device which is under some other exchange. So obviously there will be a wire leading to the hierarchical exchange, from this exchange to an hierarchical exchange, so that you can make the calls to the other end devices as well electronically. Of course everything happens electronically, but the service decisions are always going to be taken by the exchange. What decisions your exchange will take, whether this guy subscribed for this service or not, did he pay the money or not, these kind of things he will verify and make the decision whether this circuit must be established now or should be rejected. So who is making these service decisions? Our exchange is making the service decisions with the help of that piece of a software and a database that is present. Okay, great. So if you do the summary of PSTN, one system we have already learned completing PSTN, all devices are connected with a wire to their nearest switch with a wire. Switches provide services to different end devices. Yes, they provide services. That could be any service. Normally, only services possible on landline is calls. That's okay, but it's a service. Switches have automatic switching mechanism to route the calls from one device to another device based on some kind of a common numbering scheme, based on some numbers. Every device will have a unique number so that you can make a connection from one device to another device. Switches are always interconnected with one another in hierarchy. Switches won't be directly connected to other end user switches. They would be connected in hierarchy, as we have studied in the one of the previous slide. Village exchanges connected to mandal exchanges connected to district, etc., etc. But this piece of a wire is always going to be present 24 by 7. So whenever this guy needs a service, he will take the dialer out and he will dial a number. Then the details will go to the exchange. Exchange will make a decision whether to accept that service or not. If he decided to accept the service, makes a electronic connection from your electronic port to the other electronic port without needing a human being support. Electronically the connection would be made. Job done. Great. Now we are introducing our second network today, called as PLMN, Public Land Mobile Network. So PSTN completed. So Graham Bell worked out his, worked out on many days, and he invented something, and we have learned it in maybe 15, 20 minutes. We completed that. We only need to learn the basics, how the actual the technology system is working. We'll not be digging deep into it because nobody will ask you a question on a landline in the real interview. But we need to have all our basics right to understand the deeper concepts. Fundamentals must be really, really strong. That's why we started with that landline thing. But we also require it for the purpose of understanding 4G to landline calls, etc. So when you want to make a call from 4G device to your landline device, what happens? We need to understand. That's why that explanation is required. But anyway, we going into the second thing called as PLMN, Public Land Mobile Network. So what is this system is all about? They started thinking that, hey, wires are bad. The wires that are connected to end devices are actually giving us trouble, or we are losing our moving independence basically because of that wire. Maybe the wire is like 100 meters or whatever. We can only, go to that 100 meters any direction. It is restricting our mobility. So they started thinking, hey, can't we develop the devices which are communicating without these bloody wires? Can't we do that? So obviously the solution they have uh, found out after a lot of innovations, is the radio. So what is this radio and how it has become a solution? Radio is basically a electromagnetic wave. There are a lot of different types of electromagnetic waves that are there. So every electromagnetic wave will possess two properties called as frequency and wavelength. There are other properties also, but these are some of the two properties, frequency and wavelength. But these are reciprocal property, basically, this frequency and wavelength. If the frequency of the radio electromagnetic signal is low, its wavelength will be very high, and vice versa. If the frequency kept on increasing, the wavelength will reduce. Fine. Now, um, they have started giving different names to these electromagnetic waves depending on the frequency. The lowest frequency waves are called as radio. The next level frequency waves are called as microwave. The next it is infrared, that is our visible light, ultraviolet rays, X-rays, gamma rays, etc. So they started giving different names to different electromagnetic waves. Why they have given these names? Depending on for what purpose we can use these waves, and what are the different applications we can have based on the wave properties of along with this frequency. So based on that, they started giving those names. Now, uh, in reality, we can use any electromagnetic wave to transfer the data from one place to other place. Any electromagnetic wave, including visible light. We can use even light for communication. Even in optical fiber, we will be using visible light only, actually, for communicating between one endpoint to other endpoint on the optical fiber cable. So we can use any of these electromagnetic waves for our communication. Then why did they choose only radio for our communication? um, this wireless communication, because radio is possessing the highest wavelength. It can travel higher distances. In the wavelength of the signal is high, it can travel more distance. Basically, that is the story behind this wavelength. So that's why it has become favorite for us, these radio signals, because of their traveling capability with lesser power. Even the higher level electromagnetic waves, they can travel higher distances, but you need to apply the huge amount of power to make them travel to the higher distances. When you compare with the radio signals, with a lesser power, radio signal can travel much higher distance than the other electromagnetic waves. So because of that property, so they have decided that radio will be perfectly suitable, as these waves can travel much higher distances for communication. Now, how electromagnetic waves can be used for communication? How can you send the data on the electromagnetic waves? That is a different story. We will be studying that later in the form of something called as modulation and demodulation. How that modulations and demodulations work, how the data actually will be traveling in the form of a radio signal. We'll be studying that a little later. But somehow, we just blindly imagine that somehow whatever the information that we want to transfer from a device, we can convert that into radio signal. We just take it for granted to understand the present thing that we are studying. We'll dig deeper into it at a later point in time, but right now we are, by taking it granted, we are thinking that yes, the data can be converted somehow into electromagnetic signal called as a radio wave, and can be transferred from one device to another device, and the other device can receive your data. Just think it in that terms. Okay, fine. Now, how this this radio solution was built? Before the uh, actual radio solution was built, radio was known for a long time. In the older days, we used to have this kind of a radio devices spanning in a big area. where from one central antenna they used to send radio stations where you will be able to listen to news, etc., etc. So these are the transistors where you can actually set your transistor to a particular frequency, and you will be able to get the radio frequency signal from a centralized location. And when you tune into that particular frequency, these receiving devices will be able to receive that frequency and convert it back into the data and play that data for you. So this is not this is the first one of the first radio solutions that was built, but in order to transmit the signal in a very large area, they used to use very high power and a very powerful central antenna to transmit it like 200 kilometers in a from a particular central location. Okay, so the kind of solution they have built here is 1 is to n. That means one guy communicating or one guy transmitting the information to n number of devices. We don't want this. We want 1 is to 1 one communication. We want communication between one device to another device. Ultimate goal is 1 is to 1. But this is not 1 is to 1. This is 1 is to n. And moreover, these transistor devices are having only reception capability. They don't have transmitting capability. They cannot transmit back. They will be only able to receive. They have only receiving antenna. They don't have a transmitting antenna, and they are receiving on a particular frequency depending on what you are setting that frequency to. Great. So later they started thinking that, hey, why can't we have even transmitting devices uh, in the same lines? So they started implementing this solution with this centralized control room or control station in the middle, and these devices now who scattered across the geographical area, they not only receive the signal, but they can also transmit the signal. So they have made these devices capable of transmitting antennas and receiving antennas. These are typically what we call as walkie-talkies. The police personnel and military people would typically be using it in a particular location. And this transmission and reception typically happens on a single frequency. So while you are transmitting on a particular frequency, on the same frequency you will be receiving. But a device cannot actually do transmission and reception at the same time. It cannot. It cannot perform transmission and reception. Now, why it cannot perform transmission and reception at the same time? Because you are transmitting a particular frequency. If you are receiving the same frequency, it will become a echo. You will be listening yourself because whatever you are transmitting, your device is receiving it back on the same frequency. So it will become a echo. You will be listening to yourself. So that's why these devices can either only operate on transmission or reception one at a time. So they'll typically be these walkie-talkies will be having a switch. So you press the switch. When you press the switch, it will become a transmitting unit. You will talk on the device, and once you release the switch, it will become a reception unit. It will be receiving the voice from the other side. But all the devices are operating on a single frequency, so you might be receiving the information from any device directly if they are in nearby your place. So the kind of communication they have built with this is indirectly they have built n is to n communication. N guys communicating with n other guys. There is no secrecy to the whatever you speak. Whatever you speak is public. It is going to every other device. But we don't want this kind of a public communication. Now, in a public communication, there is no secrecy over data. You can generally use it only for like departments or for military kind of organizations. This will do good, but not good for individual communication. We ultimately wanted to have a individual one-to-one communication. So they started thinking, hey, why can't we do this? Direct one-to-one communication between two devices. One guy's transmitting frequency will become receiving frequency on the other side. The other guy's transmitting frequency will become receiving frequency on your side. So your transmission becomes reception for the other guy. The other guy's transmission becomes reception for you. So if we can have such kind of a arrangement, we can actually build a solution where these two devices are communicating and having, uh, you know, voice call exchange between them. But there are troubles also. What kind of a trouble we can have here? What could be the maximum distance between these two walkie-talkies? That should be dependent on how much amount of power they will be able to generate. These devices can generate. It would be dependent on that. How much power these devices can generate. That is first thing. And the second thing is when you have a large number of devices, you will not be able to allocate one frequency to one device. Not possible. Why? Because the amount of radio frequency that is available is limited. What is the reason? Because your radio frequency is basically a electromagnetic wave in one particular range. But that electromagnetic wave called as radio, because of its special properties, it would be used by the government for various operations and various department communications. So normally, government will only evacuate some amount of radio frequency and sell it to different companies to use it for their operations. Like if you take the case of India, Indian government will be auctioning this radio frequency, which will be purchased by these telecommunication companies like Airtel, Reliance, etc. They'll be purchasing this particular frequency usage and they'll be using that frequency. Nobody else is allowed to use that frequency. One which is purchased by one company should not be used by the other people, obviously. But your frequency is limited. But when you wanted to have these kind of devices, infinite number of devices, it is not possible because each and every device demands some frequency here in order to not to have interference with the other devices. But we don't have that much amount of frequency to allocate one sub-frequency to one device. We don't have that much amount of frequency available because number of human beings are large in number, in crores. In any location we will be finding thousands and in lakhs of users. So having the frequency divided to all the users is impossible in reality. Then what could be the solution? How can we build a solution with this? So then they started thinking about the actual solution. They started thinking this way: hey, we'll have the device and the device will try to send the information by using the radio signal that will be received by an antenna, radio antenna, which is on top of a building. And this radio antenna would be connected to the switch, which is making the decisions about whatever the service the mobile user is requesting, that service should be accepted or rejected. That the decisions are going to be made by this exchange or the switch, because the switch is having the database, is having the user related information, and it is having the software to read that database information. And if the software agrees to that service request, the electronic component part, the exchange part, will try to make the electronic connection with the other end device. So instead of having a wire, you are having a antenna and you are actually connecting your end device to that antenna. You are basically connecting that way. But the biggest problem here would be, if we have this kind of a solution, it is really good. But the biggest problem is with the number of users. Lot of users keep coming and say, hey, what about us? Even we wanted to have such kind of an wireless communication or wireless connectivity. Do you think we are not privileged to have this? What is the wrong we have done? We'll also pay money. Please give this kind of thing to us also. So when the number of users started increasing, then the biggest difficulty that you will be facing is what the frequencies that these number of users will be using. Now, can the operator who is building such kind of a network, can he manage that many number of frequencies, sub-frequencies, especially like one sub-frequency that is going to be allocated to each of these devices? Can the operator have that kind of an frequency range available for him to be able to serve his users? And moreover, these guys are spreading in one particular location. There is always a possibility they can keep moving around. They can keep going into different locations. They keep spreading. Even once you have decided to arrange them some radio frequency also, they won't stay stable at one place. They will be moving around from place to place. So how do we solve this? So there is a problem with your radio frequency, which the users have to use, and the amount of users are very high, and moreover they are moving from one place to the other place because we have given them freedom. We have provided freedom to these people by not having the wires. So obviously when you give such kind of freedom, they will move around. They'll keep going from place to place. So how do we solve this issues that we have? Of course, we can have this solution in place. It's a beautiful solution we can have. So we are having the exchange just like a telephone exchange, which can make decisions and make the connections with the other devices. But we are now talking the problems related to the radio part. What about the radio section? Is that really clean? And moreover, one more issue is when the distance increases further, the user signal may not be able to reach the antenna. So the distance will be so much that the signal is not able to like be received or transmitted by the mobile device. Is far away from the antenna, uh, the middle antenna that is present here. So what do you do in such kind of cases where the users are spreading into an area where there is no signal possibility because you come long, you come very far away, like really, really far away from the centralized location that you have. So to solve all these problems, they started thinking that, hey, um, we need to have some extra mechanism to implement all to solve all the problems that we are facing with these radio solutions.
तो
Or
देखिए क्या है उसमें, अभी मैंने उसमें बीटीएस आईडी नॉट डिफाइन करके डाल दिया है। रीजन ये है, सुनिए मेरी बात को, कि उसमें सेल के सामने बीएससी लिखी है, ठीक है? तो हम ये डायरेक्टली नहीं लिख सकते।
sorry, is there a question? Can you please use your mic or to the near to your mouth? Actually, I'm not getting your voice cleanly. Whoever is speaking right now. Nishant, please speak up a little louder or please go near to your mic so that I'll be able to hear cleanly.
हाँ देखो, नहीं आपको नहीं, किसी पर नहीं बोलते, बाकी हो सकता है। ठीक है।
Okay. Nishant, I did not get that question completely at all. It was a complete loss of your voice. Can you please type your question on the chat box that is available? Please type your question so that I'll be able to answer it. Your mic is not clear, for sure. All right. So while you're typing that question, I'll continue my discussion. So, how do we solve all these problems that we have? We have a distance as a problem, the amount, the range of the signal. We have the amount of frequency available is a problem. So, how do we solve these issues when the number of users kept increasing? So, they found out a solution called as dividing the whole area into something called as cells. And restrict the transmission of the users to the nearby antenna. So by doing so, they're actually saying to this particular, they have actually implemented what kind of a solution? They have divided the whole area into some number of smaller areas, and they have told these towers that, hey, you have to deal with only the users present under your geographical location. You don't need to deal with the users who are present in outside location. You don't need to um, touch upon that. So that is what they started implementing, and moreover, they have made improvisations. They have told that, hey, whatever the frequency that we are allocating to the users, instead of allocating the frequency to the users, let us allocate the frequency to a cell, or let us give the ownership of the frequency to a cell antenna. We give the ownership and tell the antenna that, hey, divide this frequency that I'm allocating you into some small pieces and allocate that sub-frequency to the users who are active or who are on a call, who are using the service. So only for the duration of the call, you keep that sub-frequency allocated to the user. After the user has cut down his call, you may remove that frequency allocation from that guy and you can shift it to some other person who is in need. Okay, there is a question here. Excuse me, any range for the station to station? Uh, Typically, range for station to station will be dependent on the amount of power that we give to the antenna. Um, Now, the amount, for example, let us work it out in two different ways. For example, there is some X amount of frequency allocated to one antenna. We can divide that X amount of frequency that is available into like 10 pieces. Suppose we can divide it into 10 small sub frequencies, which we can allocate to 10 customers. Now, in this geographical area where if we have only 10 users operating at a time, then this guy can allocate the resources to all those 10 guys. But if there are more number of users come up into this cell, like 20 guys are demanding for services, or 30 guys are demanding for services, or 50 guys are demanding for the services, because he has got only 10 sub frequencies available, it can allocate resources only to 10 users at a time. What about the remaining 40 guys who are demanding for the resource? So that time what do we do is, because based on the radio availability and based on the number of customers we have, what does the operators will do is they will try to decrease the range of the cell by decreasing the power of the transmission, by decreasing the power levels. They will decrease the size of the cell. When they decrease the size of the cell, obviously number of customers will be decreased, obviously. Now, the remaining areas, whatever the other areas that we have, we might have to cover that other areas by using, some separate towers, by using a different frequency allocated to it. So the size of the cell would typically be dependent on the number of users who are demanding the services in that cell. If the number of users increasing, you have to decrease the cell size. Now, what is the standard size of the cell? The standard size of the cell would be dependent on the the power that we use for transmitting the radio signal. That power is a parameter that we can set in the when you are setting up this network. You can set it. We'll discuss more what is this power, etc., etc. We'll go deeper into it when we are learning the LTE technology. We'll understand those things at a much deeper level. We need to get into it. We'll get into it, but we are not going so much deeper here. But we are just learning the basics. So all these cell divisions right now are making sure that every customer is basically served in that area. Okay, so none of the towers are actually facing any kind of a problem in providing the services to any of their users. The resources are available enough. But one of the other advantages of dividing this total geographical area into cells is whatever the frequency that we allocate to one cell, we can actually reuse that frequency somewhere else, because there would be no transmission interference between this cell and this cell. We can keep on repeating the available frequency. So that makes operator buy less frequency instead of having too much frequency. So we can buy only a limited amount of frequency, and we can divide that frequency into some number of pieces, and we can allocate it to different cells. So we are making sure that all the adjacent cells are not having the same frequency. All adjacent cells will have a different frequency for sure, but we can keep repeating these frequencies somewhere else. For example, we can repeat f2 here, we can repeat f5 here, we can repeat f4 here, we can repeat maybe f2 here, something like that. We can keep repeating them. We can repeat f6 here. In a um, in a remote location, you can keep repeating these frequencies. So operator buys some X amount of frequency, divide it and allocate it to each and every antenna. And from that antenna again, that frequency will be subdivided and would be allocated to different users. That was the idea. That was the total idea. So you are dividing the frequency in two times, two levels. The huge amount of, for example, operator buys like 10 megahertz frequency, and or maybe like 2 megahertz frequency operator buys, and operator divides that into 10 into 200 kilohertz each. Now each 200 kilohertz is allocated to one cell. Now in the cell again, the 200 kilohertz might be divided and to allocate the sub frequencies to each user. Okay, so one first level division is for the cells and second level division is for the users. We are using FDMA plus FDMA. What is it? We'll introduce tomorrow. Don't worry about it now. But the biggest problem we have is not that. When we have these many towers, what is the problem we'll face is this. Can we have one exchange present with one tower? Can we really do that? Let us think about that for a minute. Can we actually have one exchange for one tower? Why do we need to have one exchange for one tower? Because your exchange is the software component which is containing a database about users, whether their services should be accepted or services should be rejected. That information is present in the database. But can we keep one exchange with one tower? What happens when we keep one exchange with one tower? We have kept one exchange here, we have kept one exchange here, we have kept one exchange here. What would happen if we keep one exchange for one tower? The biggest problem is one user who is in this locality, his information gets stored into this particular database. Perfect, no problem at all. As long as this user is requesting the services by being in this particular location, this tower who is actually having this exchanges handy connected to it, it can make a decision whether the service should be provided or service should be rejected. Because the data is available in the database, you can make a decision. But the moment this user, this particular mobile device move to a different location, if we try to make a call, the call details will go to this tower. This tower, when you look into his database, it will not be able to find out the information belongs to this user, because this user's details are stored into this database, not into this database. Now, if you take landline phones, every landline exchange is having a separate database, and the landline phones are connected to that particular nearby exchange permanently, not temporarily, permanently. So every time when you make a request in a landline phone, you will be requesting the same bloody exchange. You will never change the exchanges. You will go to the same exchange again and again and will be requesting for the services. But here the scenario is, because we have let the user move, he will move from one location to other location. So if you keep one exchange with the one tower, as long as you are under the tower area, the tower will be able to determine whether your services should be accepted or the services should be rejected. I'm only concentrating right now from service point of view. From radio point of view, we can learn it. Tomorrow we will concentrate on the radio point of view. We are right now concentrating only from the service point of view, whether the services can be provided to the user or not, by assuming that somehow the radio signal will go to the tower. Somehow we are not going into the deeper details on the radio signal part right now. So even though we are having um, switch with one tower, now that became useless. All these databases have become useless because those databases are containing information related to only local users. If there are 10 users here, only this 10 users information is stored, or 100 users information is stored into this database. But the moment that user goes to the other cell, maybe from this cell to this other cell, from here to here, now this database will not be able to make a decision whether the service should be provided to this guy or not. You cannot make decisions. Siddharth, I'll give you the time for your questions. Please wait. So, what do we have to do? So they started thinking that um, we must have a centralized database where all the information must be stored in one location, so that the end users will have this independence of moving from one location to the other location, so they can keep moving. For example, if they move from here to here, because all the towers are having a centralized exchange, now every tower can go and contact that centralized exchange to find out whether the user is having the subscription capability or not to take that service. You can make a decision. So the biggest difference between the landline system and the mobile system is, in case of landline system, you will be having individual exchanges which are storing individual users' information. But when it comes to the um, your mobile phone system, you are having a centralized database, a centralized system, so that the users can move around to solve this issue. Now, one other change that they have made to this solution that is already brought in is, instead of allocating the instead of directly connecting these devices, the towers, to the centralized exchange, they have brought in the some middle components. What are these middle components? Why do we need these middle components? Can these towers directly communicate with the exchange to make the service decisions? They cannot now, because we have brought in the middle components. What is the responsibility of these middle components? They have allocated the radio resource allocation techniques to these centralized components. So whenever a end user device wanted to make a call, who allocates the dynamic radio resources to that user is not the tower. It is going to be the centralized component. Why? Why not they give that kind of a functionality to the tower? Why they have uh, made the solution complex, and why they have brought in this additional centralized components? What was the reason behind that? In the old days, the software and hardware were very costly. We are talking about 1980s and early 1990s. Software memory was very costlier. Software implementation was very costlier. But to do dynamic radio allocations, you require very complex and very complex software and corresponding hardware. So if they started implementing that kind of a complex software and hardware at every tower, they started thinking that the cost of implementation for the network will be very high. So they thought that instead of giving that solution to each and every tower, they have made a centralized one solution at one place only, a centralized device which is taking care of radio resource allocations to all the end user devices by being in a centralized place. The meaning is, if a mobile phone from here or from here or from here, anybody who requests for the resources, that resource request will be forwarded to this centralized component. That centralized component would allocate the required radio resources. It is not these towers who is allocating the radio resources. The centralized component is allocating the radio resources. Again, directly can't this solution be implemented into the towers? Is it technically possible or not? It is possible, but it was not feasible. It was not implemented to reduce the cost of implementation of the networks. So this is the most feasible solution they have found out. So instead of directly keeping the entire logic into the tower, they saying that we might need to place lakhs of towers. So that many places, if you keep this much complex software, the total cost of implementation will be very high. So we'll not do that. But now in modern technologies like 4G and 5G, we do that. We don't care about that cost, because very powerful hardware and software devices are available for cheaper cost now today. So how do we implement 4G 5G networks, we'll study later. But when it comes to this, this was the initial solutions that they have brought in. So what was the PLMN takeaway? All devices are connected to with a radio signal to the nearest base station, but these base stations or towers are going to be connected to base station controllers, who will be responsible for allocating radio resources to different mobile phones who are requesting for the services. So the base station controller's duty is to only allocate the radio resources. But um, ultimately, the devices will reach a nearby switch who will be making the service decisions. So always the switches are the ones who will decide about the services, whether a service should be provided to a user or not, because the switches are the ones who are having the databases. They can only make the decision about whether a service should be provided or not. But these devices, in order to reach a switch, they must go through this particular base station and base station controller, because base station controllers need to allocate the radio resources to the users, and they will be able to communicate, transmit the data, or receive the data to base station, from base station to base station controller to the switch. But finally, switch will be having the automatic switching mechanism to be able to route the calls to the destination based on a numbering scheme, and the switches will be making service decisions always. So it is the switches who will be making the automatic decisions here. So these switches are interconnected in a hierarchical fashion. So the last slide for us, for technical slide for us today. So in case of landline systems, services are provided by your switch, but how do the device reach the switch is with a 24 by 7 wire. The device will reach the switch with a 24 by 7 wire connected fully. So whenever you want to request for a service, you will be able to send that service details on this wire, and the switch will make a decision whether that service should be accepted or should be rejected. The switch will make up decision. But when you take your wireless communication system, the switch is connected to a central radio management device called as BSC, base station controller, and a tower to communicate with the mobile device. They are already, the connections are made. Now, once mobile makes a radio connection successfully with the tower, now mobile will be able to send the information by using all these links. It will be able to reach this exchange or your switch to request for your services. And to do a comparison now, the wire in your landline phone systems is equal to the radio signal from the mobile device to the tower to the centralized component. There is a wire. From the centralized component, there is another wire connected to the switch. So the single wire we have between the device to the switch is equal to these many links in case of radio communications. But ultimately, either it is your landline phone or your mobile device, both have to reach a switch or a exchange who will be perfectly making a decision about whether the service should be provided or not. And based on that service request, the call will be forwarded to the other side. But how to reach a switch is different in your landline phone, which is called as Pstn network, and which is different in Plmn network, public land mobile network and public switch telephone network. In case of public switch telephone network, it is through a wire, but in case of a PLMN, you doing a break journey. In order to reach your switch, you have to reach the tower to the centralized radio component. From that central radio component, finally you will be reaching to your switch. There is a break journey here. Other than this way of working, remaining things remain same. Who will be making your decisions, service decisions, is your switch or the exchange. How this radio technology work, how these towers will work, and how these central components will work, that we will be studying in our next classes. But this is where we will end for today, the technical part. Now, what next? I will introduce
Hello.
myself first. Uh, Siddharth, please wait a minute. Okay. I'll
Okay,
introduce
sir.
myself first, and after that, I'll keep the session open for your questions. Any questions that you may be having, you can ask after my introduction. Okay. My name is Banerjee, and I will be taking your sessions throughout the next 3.5 months while we are going through this training. I'll be taking the sessions. I've got around 17 years of experience in telecom domain, entirely in telecom R&D sector. Worked for major companies like Nokia, Siemens Networks, etc. for many years, and I have been working for T-Cloud for the past 7 years as a trainer. And you know, we have conducted a lot of batches at T-Cloud. This is the 107th batch that we are conducting here. So this training is repeated for multiple times. So what is the course content that we are going to have that I'll be introducing in tomorrow's session, for sure. Okay, I'll introduce that part. But orally, I will try to explain what content we'll be going through. As part of this training, we will be having 4G advanced LTE, that is called as advanced LTE or LTE advanced, and IMS, IP multimedia subsystem. So these are the three major areas that we'll be covering as part of this training. The individual topics I'll explain in the tomorrow's class. At the end of tomorrow's class, I'll explain the individual topics. And what about the 5G part? The people who are asking for 5G. If you wanted to do only 5G training, you have to join the 5G training batch, not the 4G training batch. But um, before you join the 5G training, it is mandatory that you have expert level knowledge on 4G, advanced 4G, and as well as IMS, IP multimedia subsystem to the deepest level. But if you don't have that expert level knowledge on 4G, advanced 4G, and 5G, sorry, IMS, you will never be able to understand this even a single class in 5G. You will not be able to join into 5G sessions. Okay, so 4G and advanced 4G is mandatory to understand 5G topics, because 5G is not a new technology. 5G is an improvised version of 4G. For example, you may be asking, why are we learning starting from 2G and 3G? 4G is an advanced version of 3G itself. It is improvised from 3G. So we have to understand what is the architectural changes that is going through to understand how 4G is evolved and to understand 4G. Similarly, to understand 5G, having sound and very high level knowledge on 4G and advanced 4G is mandatory, and IMS is also mandatory. We don't teach IMS in 5G part. 5G part will directly be teaching 5G by assuming that you already knew IMS, VoIP, SIP IMS part. We assume that you already knew it. So 5G subject is always on top of 4G advanced 4G. Now, if you are already working on LTE protocol testing in some company, and if you wanted to learn 5G protocol testing, then you have to enroll into 5G training. But if you wanted to get a job even on 5G projects, you don't need to learn 5G training. Reason is, uh, they won't be taking your interview on 5G, or you won't be presenting your resume on 5G. You will be presenting your resume on 4G itself, because the projects that happened so far are only 4G projects. Nobody will believe if you say that you have worked for 4 years or 5 years on 5G project. Nobody will believe that, because 5G implementation started very, very, very recently. So you cannot present your projects on 5G even though you have learned 5G, until unless you have an immediate requirement to start working on a 5G telecom protocol testing project in your company, in your present working company itself. So until and unless you have that requirement, you are not required to directly study 5G. And even if you study 5G without having the fundamental and very complex knowledge on 4G, it is impossible. Because, for example, we study MIMO, multiple input, multiple output, multiple antenna techniques in LTE. Directly by assuming that you already knew MIMO, I'll start teaching massive MIMO in 5G. How massive MIMO, like 64 antennas work. If you don't know how to work with 4 antenna concepts, how the signal transmission is going on, you will never be able to understand what happens with the 64 antennas if I directly start teaching massive MIMO subject. So it becomes impossible for you to learn 5G directly without having the 4G concepts and advanced 4G concepts. So whoever doesn't have 4G advanced 4G, you never come and join 5G. You will basically be wasting your money by joining into the training. Of course, we have the training. The starting date will be announced. If you contact our front desk, they'll tell you. You can join into the training also if you wish. No problem. It's your choice. But I'm telling you that it is mandatory to complete 4G and 5G. And of course, IoT part also will be covered in 5G itself, because 5G is containing this called as NB IoT. So we will be having IoT part also covered in the 5G section. So when we cover 5G protocol testing, you will be covering IoT testing as well, including 5G protocol testing. Both the things will be interconnected with each other, as this IoT is completely integrated in the working along with the advanced LTE and 5G concepts only, but not available with the 4G part. That is why we will be covering that section in 5G topics, not in the 4G topics. Okay, so that is the fundamental course thing. The individual course contents I'll introduce tomorrow. In the day after tomorrow and the subsequent classes, I'll be showing you all the labs and tools that we'll be having for doing this protocol testing. We are the only one who are having a lab facility for LTE and advanced LTE or for 5G in India. Nobody else will be able to give you the lab facility in India for any of these trainings except T-Cloud. That is for granted. And uh, for the next 5 or 6 sessions, these sessions are going to be completely called as the demo sessions, and these sessions are for free of cost for you. You don't need to pay any of these for any of these sessions that you have to join in the next one week. You will be joining and attending these sessions for free. only once you like these sessions, both the theory part presentation wise, as well as all the tools that we show you as part of the tools introduction and the course introduction, if you like everything in the next 5 or 6 sessions, then only you will be committing yourself and joining into this training. Otherwise, you can quit this training and you can do something else, or maybe you can join in some other training center which may be like perfect for you if you feel so. That's completely your option, and no other training center in India will give you 5 or 6 demo sessions for free of cost except T-Cloud. We are even in, exceptional in that part. We are proud to say that because nobody will believe in themselves. They will fear that you will find out about them in 2 or 3 sessions, and mostly they will escape with one session itself. They will make you try to join by just giving one demo session itself. But we'll give you enough number of demo sessions so that you will be able to make a perfect decision whether you wanted to join into this training or not. Okay, so take that as an opportunity, attend the sessions, and you can keep on asking any of the questions that you may be having, both technical questions, non-technical questions, for the next 1 week till this weekend. You can keep asking. Once you have all doubts sorted, you can actually then decide to join. You can decide to join. And now, if you wanted to have any personal questions, if you wanted to ask some questions, you can contact the front desk. They will provide my number directly. You can make a call directly to me at any time in the daytime. I mostly be free in the daytime. You can give me a call. You can directly talk to me and sort out any of the questions that you may be having in your brain. Okay, you can do that. Okay, so that is one other point. So other than that, if you have any quick questions now, if you wanted to sort out immediately, you can ask me other than the things that I have explained you.
Hi, sir. This is Sainath.
Yes.
Sir, so I work for Qualcomm as a field test engineer.
Okay.
Uh, so daily. I collect a bunch of logs, but I'm unable to analyze those logs. So we'll
We
cover
will be
those
learning the
parts.
subject very deep to the log analysis level, and each and every protocol will learn very, very deep. So you will be able to do the log analysis after this training is completed. But log analysis is always going to be a first step. You will be learning much more deeper level, and you will understand how to execute the test cases, how to generate those logs, and how to analyze it end to end.
Sure, sir.
Hello.
Thanks. Thanks a lot.
Sorry?
Hello, sir. Siddharth this side.
Yes, Siddharth.
Sir, now I'm working in erection.
Okay.
So my query that if after completing trainings,
Hmm.
you will be arranged for interview, protocol interview, or myself I will try to get
Normally, what do we
opportunity
do as a
regarding
process? I will try to explain you. Basically, we make you do a project. Okay, so once we complete the practical explanation part and everything, we'll make you do a project. The same project will be kept in your resume, and your professional resume will be prepared by us. We will help you out to prepare with your professional resume. And when you take this professional resume and started applying in normally job portals like Naukri and all that, you start getting the calls. Along with that, we will also have opportunities from our side. We also have some tie-ups with the consultancies, and we take up your resumes and forward it. Earlier, to before to this corona, they used to come to our place itself and take the interviews and recruit the people. But now we are actually like still coordinating with them, but their offices are not started yet. But by the time we complete this training, they will be resumed, and we will either resort back to that direct recruitment, or we will apply the interview.
okay. Sir, दूसरी another query I have that if after completing sessions, when they will share video, because in the first times it will be not clarity and on 100%. Without repeating or watching this video,
Okay.
it will be not clear 100%.
Okay. You will be getting the video typically within within 3 or 4 hours after the video is uh, completed. Like once the class is completed, to be able to process and take it, it will take that much amount of time. So once that minimum amount of time, that whatever is required to make the video processing completed, after that it will be available for you for accessing.
One thing I know from my colleagues, they told me that a video have a limited hours to watch.
Yes, you wanted to the video bandwidth that we are actually providing, that is we typically take it from your Amazon services, basically Amazon web services. The bandwidth is very costly. So we have to keep it limited, such that we'll be able to provide the service to every student. Okay, we are actually providing this service. We are the only one who is providing it. Nobody else is providing it. Again, that is our own innovative techniques that we have implemented there. It is not that it is not that it is a mandatory thing in the industry or something like that, but we have implemented so that it will be helpful for you. But there is some limitations on the amount of bandwidth that each and every student will be able to utilize. Okay, so we can only have that much amount of bandwidth brought for each and every student. Otherwise, all your 40,000 will go for video bandwidth itself, which we have to pay to Amazon. So that much amount of bandwidth for each and every student is not possible. So that's why we'll have some amount of limitation on the amount of time the video would be available. But even if you ask the video repeatedly, they will give you, like if you attend the class once and maybe after 8 days or 9 days, if you wanted to re-listen to the class, they will give you that class. Doesn't mean that they won't give that class to you, but the limitation would always be there. You can never take it for granted that it will be available always, or permanently available for you or something like that. No.
Mm. And also, right now I am able to join in this times on class, but after some time, after Corona, I will unable to join on this times. So can I will shift batch to another timing?
Yes, you can do that. Whenever you have any kind of such issues, you can shift the batches, or you can whenever you have any issues with your if you are working in shifts or something like that, you can attend the missed classes in the recorded form. You can do that also. It's your wish how you would like to continue. We'll support you in every in every problem that you might be having in the future related to accessing the classes in that particular time. We'll support you that. We have that system not from now. We have it from 15th batch itself, batch number 15. So you don't have to worry about it.
Sir, which topic is going on? Actually I want to join in the
Today is
morning
the
batch.
first class,
7.
Siddharth. Today is
No. I know about this class, but I want to join in morning class. Also, morning batch is going on, na?
sorry?
Morning batch is also going on, na?
Correct.
So if I not this topic is going on, if I want to join that
That
batch,
is
it will
always
be
already in the LT middle. You will not be able to join now because you won't understand this subject in a clean way if you join it now in the middle.
okay.
Okay, if you want to join all that, and if you want any queries on personal level, you give me a call, you can talk to
Okay.
me and you can sort out all the queries. It may not be interesting for the other people to listen to the queries that you are having right now. Okay?
Okay. Okay,
Any
sir. Thank you.
generic questions you guys are having, which may be applicable for everybody, you can ask me. If you have any personal questions, you can talk to me about that directly on the phone so that I'll be able to answer it happily for you.
Okay.
Okay, sir. Hello. Hi.
Yeah, Saurabh.
Hi, sir. Good evening, sir. Actually, sir, I have a total 4 year experience in telecom domain.
Uh-huh.
But I just want to know one thing. After completion of these courses, we have to maintain, we have to mention some year of experience of protocol
We
testing
will
in
convert
resume.
it. How to convert your present profile into telecom protocol testing profile? That we have done it for thousands of people so far. Most of the people who does our training are coming from previously working in telecom domain itself. Mostly, almost like 80 to 85% of the candidates in every batch happen to be from RF engineering or drive test engineering or KPI engineers or network engineers or these kind of telecom engineer people only. In all these 106 batches happened from starting from 2010 onwards. So we are in 2020 right now. So all these thousands of people who have completed it, we could able to successfully convert their earlier profiles into telecom protocol testing profile. It is not a big deal, and we have done it thousands and thousands of times. We could do it for you as well. If you have
Okay.
if you have any technical queries related to how we will convert it and all that, I'll be able to explain in the coming up sessions, like what exactly we do related to it. Okay.
Okay, fine. But my question was different, sir. Actually, a
Yeah.
little bit. Just client is aware about that that what fake experience we will just
Again,
mention in
when
our
it comes
resume.
to the fake experience and all that, that is not a mandatory thing at all. For especially for the people who are working already in the telecom domain, it is not a mandatory thing related to the fake part. So that is your individual's decision on what you wanted to do at a personal level. It is not a generic thing. So again, it will boil down to the individual choice of what you wanted to do, how you wanted to present your resume, and all that. So whatever we can do legally from our side in a proper way, we will support all that mechanisms. Okay, so even if you wanted to change your experience into a different profile completely by overhauling your resume, we still support it. By may not be directly from T Cloud, but we have some fundamental sources who can help you out in such kind of scenarios if you really wanted to do it. But we'll try to avoid that as much as possible and try to convey your resume as it is with technical changes instead of physical changes. But how to do that? We have already made a expertized solution for that, which is working from the last 10 years. So there is no need to worry for you on that particular front at all. Only the thing you are really have to worry about is whether you really wanted to do this training or not, you wanted to invest this 40,000 into this training or not, whether you wanted to invest this 3.5 months of training period or not. That is the only thing you need to decide. If you think that 40,000 is important, or 3.5 months of your time is more important than your career in the future, you can decide against it. So it is only the decision about the non-technical part that you have to take. But when it comes to the decisions related to the technical part, we will be completely supporting from our side. So we will be helping you out with the resume preparation, how it should look like, what are the different options you have, with every option what you should do, everything we'll be supporting from our side. You don't have to worry about it. Okay, you don't have to
Okay,
worry
fine,
about
sir.
that thing. We will take care. You only have to make a non-technical decision whether this is going to change your career or not. Does this training change some people's career earlier? Do you know somebody already who have changed their career by doing this training at T Cloud? So you have to think about these kind of things. You should not require to think about like how do they change my profile and all that. Leave it to us. Okay.
Okay, sir. Fine. Thank you, sir.
Yeah,
Hello.
Anurag.
Yeah, sir. Anurag here. Sir, I have one doubt. For testing, it is mandatory to know about Python,
We
C,
teach
and C++.
Python, Anurag. We teach Python, and we teach also other scripting language called as TTCN3. But these languages will be taught from very, very basics for you. You don't have to worry about learning these languages at all. We have mastered in teaching these languages. We'll be able to make you learn these languages very, very easily. The scripts writing is very easy. Don't much worry on that part. But I will introduce this course content and how to do the protocol testing, etc., in the coming up classes. So you can wait for some more classes to understand what exactly exactly we will learn and what are the subtopics will be there, etc. You attend some more demo classes because they are anyway free for you. You don't need to much worry that today itself you have to make a decision on this training, etc. So I did not even
Yeah,
introduce
yeah.
the course content and the tools and the scripting languages we learn, etc. I'll be introducing it in the coming up classes. Okay.
Okay, sure. Okay. Thank you, sir.